Welcome back. In this video, we are going to be talking about inheritance. Inheritance is a very important concept in C++, and we can define classes that model the relationship between similar types. So in other words, we always have a hierarchy and we use inheritance to model this hierarchy. So for example, in real life, you have a parent and a child, and there's a relationship which exists between this parent and child. So in C++, you can model this parent-child relationship using inheritance. So for example, take a look at the code here. I have defined a class animal, and if I scroll further down, I also have another class of type chimpanzee, which is inheriting from the animal class. And how do I write that, or how do I express that? I use something called an inheritance list. So in other words, I say that the class chimpanzee is publicly inheriting from the class animal. I use a colon, and after the colon, you say that it's publicly deriving from the animal class. So with public derivation, pretty much all the all the entire public interface of the animal class becomes publicly available in chimpanzee class chimpanzee as well, becomes part of the public interface of the chimpanzee class as well. Now there are different types of inheritance. You have private inheritance, and you also have protected inheritance. So I would be covering this in a separate video lecture. This is just an introduction to inheritance, so we're going to be using only just public inheritance. And since there's just one base class here, we call this single inheritance. But you can always have multiple base classes. So for instance, a child can have two parents, right? So in this case, this is one parent, and we call that single inheritance. So let's scroll up again, and as you can see here, the animal class um, has a certain number of legs. I modeled the characteristics using number of legs, the color of the animal, and the habitat in which you can find this animal. So it's a base class, right? And what I'm trying to say here is that a chimpanzee is a type of animal. So when you have the is a relationship, you always use public inheritance. So the chimpanzee is a type of animal, and that's what is expressed by this specific piece of code. So let's move down to the public interface of the animal class. You as usual, you have the constructor, and you also have the getter functions where you can get the number of legs, the color, and the habitat. All that is what we already know. Now let's move further down. This important concept of virtual functions. So when do you use a virtual function? Now the animal class has its own version of the move and display functions. Now when you know that the child class is going to have its own version of the move function. For instance, this is a generic move function. Of course, there's no logic here. Assume that you have written a function which expresses how the animal is going to move. Now a chimpanzee might have its own way of moving. There are some animals which walk on four legs, and there are some animals like chimpanzee which walk on two legs. So this function expresses how an animal generally moves. Similarly, this function display just displays all the characteristics of the animal class. Now we know that any other animal, say like the chimpanzee or maybe the lion or the tiger, now these are all types of animals, and they are going to have their own version of the move and display functions. When we know that that is a condition that's going to be true, we always declare something called a virtual function. Now this tells the compiler that this function is going to be overridden in the child class. Now let's move further down. Something that's very important and very necessary when we have classes which are modeling inheritance is the base class should always have a virtual destructor. So this usually ensures that when you are allocating memory on maybe the heap, and you're trying to destroy an object, that object gets destroyed properly. Because let's say you are creating an object of type chimpanzee, Now the chimpanzee object, as I said, inherits from the animal class. So it's going to contain an animal part in addition to whatever is specific to the chimpanzee class. And when you create this object, that's how it's going to be. And when you destroy the object, it should destroy both the animal part as well as the chimpanzee part. Just assume that the chimpanzee object is going to contain an animal sub-object. Now that's why we need a virtual destructor, to ensure that destruction happens properly. So construction usually happens from the base class. You construct the base object and then you construct the child object, and destruction happens in the reverse direction. So you got to destroy the from, let's say, from the chimpanzee class inside outwards, or however you look at it. So you destroy the chimpanzee object portion first, and then you would destroy the animal portion of the object. Now, to ensure that proper destruction, you always need to declare a virtual destructor. Alright, now let's go into the chimpanzee class. So as I said, a chimpanzee is a type of animal, and that's what I've tried to model here. And it has its own characteristics. So that's the reason you see number of hands as a separate member variable here. And when you initialize the chimpanzee class, you have to initialize not just the chimpanzee's specific characteristics like the number of hands, which is done here, but you also have to initialize the animal sub-object, right? So that's the reason I'm calling the animal constructor here. So a chimpanzee object contains the animal sub-object as well. Now this is a very important part of the chimpanzee class. This is where the move and display functions are overridden. And the latest C++ standard provides us with a tool, provides most programmers with a tool using this override keyword. This ensures that you use the same signature of the function, right? So if you have move without any parameters here, so it's just got an empty parameter list, you should override with the same signature. And in case you change the signature, so for instance I decide to do this, as you can see, the compiler has already flagged an error, and that is possible only because we use the override keyword. For instance, let's say I remove the override keyword and I do this. Now the compiler doesn't crib, but you're actually not overridden the function. You have created a completely different function, and that may not be what you intended in the first place. You really wanted to override the function which is declared and defined in the base class. So that is the reason why it's recommended to use the override keyword. So now the chimpanzee class has its own version of the move and display functions. As you can see, the chimpanzee class also has a function which is found only within the chimpanzee class, the talk function. I'm assuming here that a chimpanzee can talk as well. So this function, there's nothing virtual about it. There's no overriding or overloading here. It's all very specific to the chimpanzee class. So it's very much like modeling a parent-child relationship from the real world. Children have their own characteristics and traits in addition to the traits that they inherit from the parents. So let's look at how we can test this little bit of code. Let me quickly go over it. So I'm creating an object of type animal. I call the display and the move function. Nothing special here. We know what's going to happen. And there's one more thing I have done here. I've declared a pointer of type animal, and I'm storing the animal object in that pointer, and I call the move function. No surprises here too. We know which function it's going to call. It's going to call the move function from the animal class. Next, I create an object of type chimpanzee, and I call the display move and talk function on the chimp object. No surprises here too. We know what it's going to call. Anyway, let's place a breakpoint here and let's see what happens. So alright, so we have hit the breakpoint. So we've called animal1.display and animal1.move. As you can see, .display for the animal class has been called, and we also have animal is moving. So now we have stored, we're going to be calling the move function with the animal pointer. Let's see what happens. So as you can see, it once again calls the move class from the animal animal class, move function from the animal class. Alright, so now let's continue. We have the chimp object created. So what I can do is let me place breakpoints in all these places so that you know that control is flowing. So when you call chimp.display, it goes in the display function of the chimpanzee class. As you can see here, we are calling the appropriate function. Next, chimp.move calls the chimpanzee move function. Chimp.talk calls the talk function. Now comes the magic. So we have a pointer, which is a base pointer. We call it a base pointer, and it's storing the address of the chimp object. Now this is possible in C++, and it's possible only because of inheritance and also something called as dynamic binding, a polymorphism. So with dynamic binding, you have a base pointer, and you can always store an object which is related to the base class. So in this case, the chimp object is a child of the base class, and we have a base pointer here. The base pointer can point to a child object. It can also point to an object of its own type. So that's what we saw here. A pointer was initially pointing to the animal object, and now it's pointing to the chimp object, and this happens at runtime. The compiler doesn't know anything about this. It happens at runtime, so that's why it's an example of runtime polymorphism, and it's also called as dynamic binding. So when this happens, the move function that gets called is going to be the move function of the chimp class, because that it depends on the type of object that is being what can I say, the type of object that is going to be exposing its public interface, or in other words, the base pointer doesn't really know at compile time what it's going to be pointing to, and it's only at runtime that it gets bound to this specific object, and the function is now going to be called on that specific object. So it's the move function is going to be called on the chimp object. Let's see what happens. So as you can expect, it goes into the chimpanzee move function. Once again, the display is going to be called on the chimpanzee display function, and that's it. So when it comes to dynamic binding, it always is a very powerful concept, and it has to be used with care. It can be also used when you do not really know the runtime behavior, or you cannot predict the runtime behavior. So that's when you will always declare something called as a base pointer or a base reference, and behavior can change depending on the type of object that is bound at runtime. Now let's try doing this. So I've got a pointer.talk. Let's see what happens. As you can see, the compiler has already flagged this as an error, and that's because a pointer is a pointer of type animal. Now the animal class doesn't really know anything about the talk function. All it knows about is functions which are a part of the animal interface. So it only knows about the two virtual functions, move and display. Now it does not know anything about the talk function, because the talk function is very specific to the chimpanzee class, and that's what we see here. So a pointer is a base pointer. It only has knowledge about the animal class, and that's the reason it cannot be used to invoke the talk class. So that is going to be flagged as an error by the compiler. So this is all that you need to know about inheritance to get started. The upcoming lecture will definitely give you a lot more detail about the different types of inheritance, the access specifiers. There's one small point that I would like to make. As you can see here, the animal class has private variables and the public interface as well. In addition, you also can have something called the protected interface. So let's say I have something like int c, float d. Now what does this mean? This means that the variable c and d can be accessed by the inherited class, by the class that's a child class, by the derived class. So whenever you place anything in the protected section, So protected variables or protected members can be accessed only by the child classes. They cannot be accessed by any other classes. So you do not really want it to be private, because if you place it as private, even even the child or derived classes cannot access anything that's part of the private interface. But you still need something to be accessed by just the children, and that's when you will use the protected keyword. So that's it, folks. This is a small introduction to inheritance, and I'll see you in the next lecture.